My name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving math problems out of this book here, the GMAT Official Guide 2019. If you do not own this book already, purchase one immediately. You're going to need it. Today is our lesson number 10. Day 10, we are on page number 155. We're going to pick up from the very first problem that you see there on page 165, which is a geometry problem, and it looks something like this. From problem number 61, the very first one. And the question simply is, what's the ratio of angle B to A? Before we even worry about the picture as to what the picture looks like, the most important part to pay attention to here, which is the very common mistake, is to pay attention here to the fact that we're being asked for the ratio of B to A, not A to B. So in your haste, you might end up saying A to B, and that will be no good, which is exactly what I did when I was doing the problem. And lucky for me that when I inadvertently pick the answer of B to A, that answer choice actually is not one of the answer choices. But that's also always not the case. If that answer choice had been one of the answer choices, in other words, had the reciprocal of the right answer had been one of the answer choices, I would have picked it out of my sheer carelessness. Don't be like me. So, here we go. Pay attention. So here's our angle A, here's our angle B. We are told that this is the right angle, which is a very important bit of information. We are told that this angle is y degrees and this is y plus 10 degrees. Y plus 10 degrees. Well, it's very straightforward. In other words, however big this angle is, this is 10 degrees more than that. But this angle is 90 degrees. It's a right angle triangle. In other words, if this is a right angle triangle, then the sum of these two has to be 90. If the sum of these two has to be 90, then the smaller angle, given the fact that the bigger one is 10 degrees more than that one, this one has to be 40 degrees. And if that's 40 degrees, then this is 40 plus 10, which is 50 degrees. And that's your angle A. And we're looking for a ratio of B to A. We're looking for a ratio of angle B to angle A. Angle B is 40 degrees. Angle A is 50 degrees. Divide top and bottom by 0, and we end up with 4 to 5. The answer is 4 to 5. And as you look at the answer choices, you will see that answer 4 to 5 is D. But like I said before, lucky for me, there is no answer choice which says 5 to 4. Had they given one answer choice as 5 to 4, I would have been done. Paying attention is always important. Let's go to the next one, number 62. Otherwise you can see it's a very, otherwise as you saw, it was a very simple problem. Number 62. They're looking for approximate value. They're looking for approximate value of 7/8 plus 1/9 over 1/2. It says that the value of this quantity that you see on the blackboard is closest to which of the following value? Is closest to which of the following value? It doesn't say value of this quantity is equal to which of the following. It doesn't say which it is equal to, it just says it's closest to. In other words, we're looking for the approximate value. This quantity that we see is approximately what? That's what they're saying. So let's do it, shall we? So here's what we're going to do. So this quantity that we see here is approximately equal to, we see 7/8, and this 1/9 that we see here, let's approximate that 1/9 as 1/8. We're going to approximate this 1/9 as 1/8. Okay? Over half. The half is going to remain half, and we are done. 7/8 plus an 8, 7/8 plus an 8, 7/8 plus an 8 is just a 1. It's just 1. So it's just 1 over 1/2. And how do we divide a numerator by the fraction? We simply take the numerator, which is 1, and we multiply it by the reciprocal of the denominator. 1 over 1/2 becomes 1 times 2 over 1, which is just 2. And I'm fully cognizant of the fact that this step was not necessary. This baby step that I showed you was not necessary. I am fully cognizant of it. Yesterday in the lecture we came across this word pedantic, and I was looking up in the list of vocabulary words that we learned in our vocabulary videos, and I couldn't find which day we learned it. I looked it up later on. It was day number 69. If you're interested in improving your vocabulary, and I see no reason why one wouldn't be, just type in GMAT vocabulary words, GMAT vocabulary words, day 69, and the video will pop right up. Cognizant, we just used it. It just means to be aware of something. I was fully cognizant of the fact that I did not need to show you the baby step, but I did it nonetheless. I don't know why. Don't ask me why. Cognizant would be day number 42. Watch the video. You will learn that word along with several other interesting and useful words. Words that are not only useful and interesting just for the perspective of GMAT, but words that are good to know. When you write, when you speak, when you open your mouth, you don't want to end up sounding like a high school graduate. You want to sound like somebody who's shooting for the MBA, obviously. That part was also not necessary, I know. It was gratuitous. That sermon that I gave you was gratuitous. It was not needed. It was not needed. It was not necessary. It was unneeded, unwanted, unrequired, uncalled for. It was unwarranted, gratuitous. Learn the words. Improve your vocabulary. Improve your vocabulary so that the person who is talking to you does not have to wonder, should I bring down the vocabulary level so that this other person can understand me? I just want to speak to you the way I want to speak to you without having to worry about vocabulary. That was day number 47. That little sermon that I gave you, of course you were fully aware of it, you were fully cognizant of it. It was gratuitous. That sermon was not necessary. It was unwanted, unneeded, unrequired, uncalled for, unwarranted, superfluous. You understand? Let's keep on going. That was number 62. 63. In 63 we have a positive 2-digit integer, or rather integers. We have two positive integers, x and y, and we are told that they have the same digits, but in reverse order. My handwriting is atrocious, but in reverse order. In other words, if one is 73, the other one is 37. If one is 21, the other one is 12. You get the idea. Of course, it simply is, which of the following must be a factor of, which of the following must be a factor of x plus y. Which of the following must be a factor of x plus y? And here are the answer choices: 6, 9, 10, 11, and 14. Before we get going with this problem, we have to understand the terminology, we have to understand the language. What does it mean? What does it mean for one number to be a factor of another number? It says, which of the following is a factor of this quantity? What does it mean to be a factor of some quantity? In other words, which of these following is a factor of 70? Can you tell me? Which of these following number is a factor of 70? Pretend that x plus y is 70. So in which case the question would reach, which of the following must be a factor of 70? What does it mean to be a factor of something? To be a factor of some quantity means that this number, any one of these number here, is evenly divisible. Can we divide 70 evenly by 6? Since 70 is not evenly divisible by 6, 6 is not a factor of 70. In other words, 70 is not a multiple of 6. That's what it means. To be a factor of something means that 70 must be a multiple of 6. 70 is not a multiple of 9. In other words, we cannot divide 70 by 9 evenly. 10 is a factor. There are two of them here. 10 is a factor. You see, that would work. 10 is a factor of 70, and so is 14. 14 is a factor of 70. I hope. Yes, 14 times 10 is 140. 14 times 10 is 140. Therefore, 70 must have 5 14s. If 114 is made up of 10 14s, then 70 must be 5 14s. Of course, 14 is a factor of 70. In other words, 70 is the multiple of 14. 70 is a multiple of 10. 70 is not a multiple of 11. 11 is not a factor of 70. 9 is not a factor of 70. 6 is not a factor of 70. The question is, if we have two digit positive integers where they have the same digits but the digits are reversed, then their sum, which of the following must be a factor? Which of the following must be a factor of the sum of these two integers x and y? Enough talk, let's do it out, shall we? Let's do it out. Just do it out with simple numbers, and that's all it is. So let's start with something simple. Let's suppose the number is 12. If number is 12, if x is 12, then y must be, x and y have the same digits, but in reverse order. See, that's the 2-digit positive integer. X is the 2-digit positive integer, and y must be 21. 21 has the same digit as 12 does, but in reverse order. Now let's find out the sum, which is the x plus y. The sum here would be 3 and 3, 33. Can we divide 33 evenly by 6? The answer is no. 33 will not be divisible by 6 evenly. 33 will not be divisible by 9. 33 does not go evenly into 10. 33 does not go evenly into 14. 33 is a multiple of 11. 33 is a multiple of 11. In other words, the sum of these two integers x and y, such that they have the same digits but in reverse orders, if that's the case, that the sum of these two integers is a multiple of 11. Or, which of the following must be a factor of the sum of these two integers? 11 is a factor of x plus y. 11 is a factor of their sum. We can try one more if you like. Let's try something else. How about 32 and 23? And again, we're going to get 5 and 5. And 55, as you can see, is a multiple of 11. You can try one more if you like. How about 42 and 24? You get 6 and a 6. You see that? Even when we get to higher numbers, let's do it on the top here so we can see it properly. Even when we get to higher numbers, see here I'm keeping the digits low on purpose, but even if we were to get to higher one, the highest possible one would be 98, because we don't want the same digits. Because if they're same digits, then there is no point in it makes no sense to talk about reversing the digits. We can't have 99. 98 is the highest we can have. The reverse would be 89. Let's add them up, shall we? 8 plus 8 would have been 16, so 8 plus 9 is 17, 17, carry 1, 17 plus 1 is 18. And if you were to do it out, 180 is a multiple of 6, 180 is a multiple of 9, but 187 is not a multiple of 6 or 9. 180 is not evenly divisible by 10, and 180 is not divisible by 14. If you were to try it out, you will see it does not work. But 187, that's 187 is what I meant to say. 187 you will see is not divisible evenly by 14, but if you were to do it out, you will find that 187 is indeed a multiple of 11. And I can show it to you very quickly if you like. 187 we're going to divide by 11. 187 divide by 11. How many 11 does 1 have? 1 has no 11. 1 is too puny to have any 11s. It's too puny. What does it do? It goes to 8 and joins it. It joins forces with 8 and it becomes 18. How many 11 does 18 have? 18 has 1 11. 18 has 1 11. After we take away 11 from the 18, what do we have? We have a remainder of 7. What happens to that 7? That 7 goes and joins this 7 and becomes 77. Aha! And 77 has 7 11s. In other words, 17 times 11 is 187. In other words, 187 we can clearly see is evenly divisible by 11. But 187 is evenly divisible by 11. In other words, the sum of the two integers is a multiple of 11, or 11 is a factor of 187. It's the same thing. You can do one more if you like. How about we do 7? How about we do 7 and 6? 6 that will be 13. Carry 1. 13 plus 1 is 14. Is 143 divisible by 11? Let's find out quickly, shall we? 143 divided by 11. 14 has 111. After we take away 11 from the 14, we have a remainder of 3. What happens to the 3? The 3 goes and joins to 3, becomes 33. And 33 has 3 11s. In other words, 13 times 11 is 143. As you can see, 11 is indeed a factor of 143. 143 is indeed a multiple of 11. One last one. We did 9, 8, 7, 6. How about 5? Well, 5, 4 would not work. Why would 5, 4 not work? 5, 4 because it only goes up to 9. We want to go more than that because this will be 99. This is too easy. So let's do, how about 5 instead of 5, 4? How about 5, 7? 57 and 75. Let's find out very quickly. 7 plus 2 is 12, carry 1, 12 plus 1 is 13, 132. 132 divided by 11, 13 has 111. What happens to the, after we take away 11 from the 13, we have a remainder of 2. What happens is the 2 goes and joins the 2 becomes 22, and 22 has 2 11s. As you can see, 132 is indeed a multiple of 11. 11 is indeed a factor of 132. The answer is 11. Which of these 5 quantities that are given to us happens to be a factor of the sum of the two integers that we have, x and y, where the digits are reversed? The answer is, among the 5 quantities that are given to us, 11 happens to be the factor of the sum of the two integers. That was number 63. Don't try to do it algebraically, don't try to do it in abstract way, just make up numbers. Keep it simple. So here in the next one, number 64, in number 64 we have a sequence. We are told of 8 numbers. And we are told that each one is one more than the last. Each one that comes after it is one more than the last. The sequence begins with -5. The question simply is, how many positive are we going to have? How many positive are we going to have out of these 8? The simplest, the easiest, the quickest, the most economical way here is simply write them out. It may seem counterintuitive that, well, you might think that writing all 8 of them out, it takes time, but actually, as I said, it is counterintuitive. Just do it out. It is actually faster instead of trying to take a chance and thinking about it. Just do it out. If we start with -5, if we add 1 to -5, we get -4. One more than that is going to be -3, and then we have -2, -1, and then what happens? This is the part that happens, which is the part that they're hoping that you will forget. They are hoping that you will miss that. What happens after -1 is that if you add one more than -1 is 0. And they are hoping that most people will forget 0 and they will go from -1 to 1. Don't do that. So how many do we have so far? We have 2, 4, 6. We need to go 2 more. There we go. 1 and 2. There we go. But there's your answer. How many positive integers do you see there? In a sequence of 8 integers, where each one after the first one happens to be one more than the previous one, and if the sequence begins with -5, and each one after the first one happens to be one more than the last one, then in a sequence of 8, in a series of 8 numbers, only 2 of them are going to be positive. As you can clearly see, only 2. And that's your answer choice, C. And that's all it is. There is not much there. Just do it out. As I said, keep it simple. And the right answer will pop right out. I'll see you tomorrow, okay? I'm going to stop right here. At the end of the first column, we're going to stop. Tomorrow, on day number 11, we'll do 65, 66, and 67. Okay? Bye now.